Hi, I'm Sadman Amachanto, and I programmed the following AI classes. Before I start analyzing the code, I would like to explain in high level the logic of the program. Each AI is instantiated with certain probabilities that reflect their behavior in the gameplay. These probabilities are determined randomly, making sure that no two AI or gameplay will be alike. Each AI is also allocated targets based on their role. For example, if the AI is a sheriff, then the target roles are outlaws and renegades. The target role for a renegade AI is updated during the gameplay, as initially its target role is deputy and outlaw, but after one of them dies, it's the sheriff. The main concept of how this AI makes its decision is based on state vectors. So the probability state vector in this game is as follows, where each element of this vector represents the probability of it being a certain role. For example, in a game with 5 players, the probability of the AI being a sheriff is 1/5. The probability of the renegade being a AI being a renegade is 1/5, and so on. After the sheriff reveals his role, the probability state vector for the sheriff is as follows, and for all the other AIs, it updates to match the new configuration or number of players in this game. Each AI assigns a guest role to all other AIs, and that's done by extracting the maximum element of the state vector and mapping the element number to the role assigned. For example, in this game, after the sheriff reveals its role, the guest role for any AI would be this element 1/2, as this maps onto an outlaw, and this makes sense because outlaws have the highest probability in this game. The update process of the probability state vector is as follows. After each turn, if an AI helped the sheriff while everyone is alive, the probability of it being an outlaw is decreased by a certain skeptic probability, which is determined whenever the AI is instantiated, and the probability of it being a renegade or a deputy is increased by that same skeptic probability, which, again, if you look at my code, is determined whenever it gets instantiated. If an AI shot the sheriff, the probability of it being an outlaw gets increased by by a certain probability, and the probability of it being a renegade and deputy gets decreased by that. If someone dies and the role is revealed, the state vector is updated based on the new number of players, as explained in this process. After someone died who is not a sheriff, one of the player or the AI who previously helped the sheriff, if they start shooting at them, then the probability of that being outlaw is decreased by the skeptic probability, and the probability of that being the renegade gets increased by the skeptic probability times a random variable k, and the probability of it being a deputy gets decreased by the skeptic probability. This encapsulates how the gameplay of a renegade may be, and helps the AI make very accurate guess rolls. One thing to note is that the state vector is always normalized. So now that we understand how these probability state vectors work, let's look at the pseudocode that the AI uses. Upon instantiation, we assign behavior parameters to each AI, which can be shown as follows. All these AIs, like willing to keep coward dice, willing to trick, willing to keep normal dice, are just certain probabilities that gets instantiated to each AI. After that, an AI understands who their target role is based on their own role, which is deterministic in nature. And then the AI assigns the probability state vectors to all other players, and using that in the method that we described previously, it assigns a guess role to all the other players. Next, the AI decides which dice to roll if the expansion pack is used, and this is also done stochastically. Then it decides on which dice to keep, and this is a function of the AI behavior as programmed by these probabilities. The health points of that AI, the proximity to the target rolls of the AI, and the number of certain dice face rolled. After the AI decides which dice to keep, it determines how many times to roll the dice and does this process all over again. The number of times that the AI wants to roll the dice is also a function of the AI behavior and the type of dice is rolled. The AI then evaluates the kept dice in the following order. Arrows goes first, broken arrow then, beers, whiskey, all types of bullseye, Gatling, and duel. Then the AI resolves the dice with the following logic, and I included all the logic for all the different phases in here. Due to time constraints, I'm not going to go over all of them, I'm just going to explain one of them in this case. So for example, if an AI rolled a beer and kept the beer, it will resolve it as follows. If the health of the AI is less than a certain threshold, the AI would drink the beer itself, or the AI would give the beer to the sheriff if it's a deputy or if it's a renegade in the first round. And if the AI was an outlaw, it would give the beer to whoever is shooting the sheriff. And if the AI was a sheriff, it will help whoever helped it. Similar deterministic logics and stochastic logic is explained here for all the other dice rolls. There's also a certain probability that the AI will make a random turn to trick other players and on the other AIs. There is a constant check going on after the dices have been resolved that whether the game is over or not. After the turn of the AI ends, all other AIs updates their probability state vectors based on this AI's turn. The turn is then passed to the next AI. And this pseudocode is implemented in this AI class with all these functions. And the simulate AI class is the class that instantiates this AIs over here. And it also, this simulate AI is a driver class, and is a class that helps integrate the AI class with the character classes or the user control classes in the main function of the game functions class. Thank you.